Hello, I'm Vincent Saxtetter, and this is my new channel, After the Age of Fire. Um, the main point of this first episode is to introduce myself a little bit, and then to introduce the main topics of this channel, what this channel will be about. Okay. Um, so, First, I should just tell you very briefly something about myself. I'm an American. Um, I'm a theoretical physicist. I've spent more than 20 years at different universities and research institutes around the world um, doing theoretical physics, especially things involving computation. I have a lot of expertise in computation, including supercomputers. Um, you don't need to know about supercomputers or theoretical physics to follow this channel. I'm going to keep things very simple so that just about anybody can follow, but I just want you to know my background, and that background really sets the direction for where I'm going with this channel. I have a lot of foreign experience, and that's deliberate. I'm deliberately trying to say something with my choices about where I live, and that includes around 20 years abroad in Europe and in Asia. Lately it's been mostly Asia, and I live in Asia right now. Um, I'm married. I'm a Roman Catholic, which is a kind of Christian. I'm from a very large family, and my family, my own family is not as large as my family of origin, but I still have several children. Okay. So I just want you to know, because all these things will influence at one point or another the development of this channel. Okay. Um, I want to start off the content after my introduction by saying that we're in a very special time in human history. Um, it's unlike any other time, and perhaps you already know that, but what I mean something specific. I mean that for somebody who is able to look at numbers and and who maybe has some physics ideas in the back, but maybe isn't a physicist, but certainly for a physicist like me, I can look at what's been happening in the world in terms of energy use and many other things for the last 250 years, and I think just about anybody can can make some predictions, accurate predictions about what's going to happen over the next 250 years on this planet. So it's possible to see broadly what's coming up on the menu for next 250 years. And I'm talking about the big things. I'm not talking about who's elected, which political party dominates, which pop group is popular, or or wars. Okay, I'm talking about more broad things, things that will affect everyone, and trends. Okay, and it's possible to see today what those trends are going to be. Um, so the point of and so I'm going to explore the last 250 years and where we are now, and then what's coming up. And and the main point here is to try to give you a way of preparing yourself and your family, your friends, for what's coming up and what's useful, what's not so likely to be useful. Okay. Um, of course, I'll unpack that more and more over the episodes, but that's just a lead in. Okay. And then I just want to tell a little bit about the origins of this channel, of what I'm trying to say here. And the origins go back, uh, well, I think throughout my travels, and I've been trying to observe the world, trying to understand whatever I encounter, and I've been encountering a lot of things. I could tell a lot of stories. But in 2019, I was in the United States, and I was teaching at a university. Um, and I was asked to teach a course for non-mathematical students, students who had no intention of doing anything pertaining to math or medicine or engineering, probably literature or humanities, okay? And I was supposed to teach a physics course to these guys. Their one physics course for their 4 years, their one science course for those 4 years, and I could teach about whatever I wanted. Um, I could design the course, and I did. And I thought about what do I really want to tell these students, and what's most useful to them. Okay, how can I, as a physicist, a theoretical physicist, say something useful to these guys? And I began to think, well, what's coming up in their life? What's coming up in their next 50, 70 years before they die? And how can they prepare for that? As I thought about it, I began to realize that just by thinking about the numbers of what's been happening for the last 250 years, I can tell them a lot that they probably don't know. Um, so I tried during those months to go through and explain to them what the trends were, what's happening, and what's coming next. I'm not sure how well I did, but I certainly, by that time I was done, I had done a lot of research, and I had an overall storyline um, of what I wanted to say and how I wanted to present it, and how to explain things so that people understand where this is coming from, what we know already about the human race, what we already know about our situation, what's been going on for the last few hundred years, what's happening now, and then what we can deduce about the future and about how to act in a way that's adapted to what's coming up. Okay, so um, part of that was when I first thought about what to teach, I looked at apparently someone before me, teaching the same course before me, had chosen to use a particular book that was a popular book not too long ago called Physics for Presidents, and it meant to explain some of the basics of energy use and technology and green energy and so on, supposedly in a way that a president could use to make decisions about whatever a president needs to do. And I looked at the book, and it was very interesting, and I understand why it was popular. I liked it. But in the end, I didn't really like it because I felt like um, the book kind of said things that a president might want to hear. The things that, when you're talking to somebody powerful, you don't want to disappoint them or displease them. And you say anything, you say, well, if you want to try that, do it. If you want to try the other thing, do it. If you want to try something else, do it. And just see how far you get. It'll be great. And I realized that this might be the appropriate thing to say if you want to keep your job and maybe advance in your job as an advisor to a president, but it's not really what you want to say if you want to talk to a real person about what really matters in their life and be a real help to them. So that sort of informed me. I was trying to think about what could I say to these math illiterate students, most of whom didn't really know how to multiply or divide, and maybe not to add or subtract either. That was the level of math literacy I was dealing with at this university. It was a real university too, uh, but and so I was trying to think, what could I say for real people that they really need to know? And so I came to think of what I was saying not as physics for presidents, but as physics for humanity. Okay, and for some years, the topic of these notes and this thing that I was working on was called Physics for Humanity. Okay, that's how I thought of it. Okay, and just to say more clearly, what I tried to do as I developed this after the course and during the course also, I tried to make sure that there's nothing in here. You're not going to face anything as you listen to this channel that requires more of you than the ability to add, subtract, multiply, and divide. Okay. If you know how to do those four things, and maybe you should know something about percents too, percentages, that should be enough. Okay, you'll be able to get. I'm trying to explain things that many of which have a technical background, and I've spent a lot of time in the weeds as I prepare this, working on the technical background. It can be pretty fathomless, uh, but I'm make sure to present the topics in a way that any person is able to do some logical thinking and can do some basic math. I mean, really basic math, and knows what it means to add, for instance, uh, can keep up. And I also think that for many people, it's a little difficult to know what to make of graphs, of graphic, bar charts and things like that. And so I just leave that out entirely. If I can't say it in words, I don't say it. And in general, I can say things better in words than I can do with these charts. The charts are not precise. They leave lots of room for misunderstanding. So I just leave them out. Okay. One more thing, I came across a book where the author, this book about renewable energy and other energy sources, and he chose to use a particular way of describing the energy called kilowatt hours. And I thought that was inspiring, it was useful, but I thought I could do one better. And the one unit of energy, the one way of describing energy that I think everyone knows about is calories, because we eat calories every day. We see them on our labels. We worry about whether we're eating too many or too few, and so on. So in this channel, I'm going to be talking about calories. Okay. I'll be talking about how many calories your car uses while you're driving down the road. Okay, I'm going to be talking about how many calories the Earth receives in sunlight every day. I'm going to be talking about how many calories are released by a nuclear reactor, okay, or by your hairdryer, okay, or when you heat up a bathtub of water. Okay, I'll be talking about calories, and so that I hope that this is more relatable and you can grasp more the situation that we're in today regarding energy use. And a big focus, especially in the first third or so of this content, will be our energy use. That's what I'll get started with. It'll be sort of the motive and where the energy comes from. Well, not literally energy, it'll be the inspiration for everything that comes after that. I want to tell you, by the end, we won't be talking about energy so much anymore. We'll be talking about all sorts of issues of culture and geopolitics and language development, and and then finally ethics and faith. Okay, but at the beginning, this is going to be about calories. Okay, so let's talk a little bit about calories. Okay, so if I just want to say, and maybe you haven't heard it put this way right now, but I want to tell you how much an average person around the world uses today, how much energy we use today, and what are some questions one could ask about that number. Okay, so by the way, this channel is all based on content that I've been writing for a book, and the book is, here it is, a draft of it. It's After the Age of Fire. Okay, it used to be called Physics for Humanity, and I hope to publish it someday, hopefully soon, but it's taking a while. It's already, if you include the footnotes, and there are an awful lot of footnotes, because I want to make sure every detail is actually backed up. It's 450 pages already, and this channel is meant to take some of those ideas and make them available in video already before I can get the book finished. Okay, but let's talk about calories. How many calories does an average person around the world today use? Okay, and so you know about, well, we all need roughly 2,000 calories per day in our diet. If you have fewer than that, you starve to death. If you have much more than that, you become obese and then you die. Okay, if you keep on eating that way. Okay, um, so I'm talking about exactly the same calories that we eat. Okay, but if you look at all the calories that an average person uses, an average person uses around 15,000 calories per day for crops, lumber, and uh, and for fodder for animals. Okay, so there's food that we eat, there's fodder for our animals, and there's lumber. Okay, and that's roughly how much we harvest each year from our land. Okay. Aside from that, we use another 46,000 calories per person from other sources. Okay. So the sum total is 61,000 or so. Okay. And let's talk about what those other sources are, the 46,000 calories per person. That means we're effectively eating for 30 people right now. Each person is roughly eating for 30 people. I mean, not exactly eating, but most of it is getting burnt. Some of it's getting turned into toilet paper, into houses. Some of it is being used as fodder for our animals. But that's roughly how much we're using. We're using as much as 30 people would eat, each person around the world. Okay. So let's see where that energy comes from. Well, let's see. Looks like 2,100 calories, so roughly the same amount that you eat, comes from nuclear power. Now, only less than half of that gets turned into electricity. The rest gets turned into waste heat. Okay, so the amount that gets turned into electricity from nuclear plants each day, this is 46,000 calories per day, not per year. 850 calories per person per day goes to electricity, nuclear electricity. Okay. There's another 1,300 calories that comes from hydroelectricity. That means dams. There's another 430 calories per person per day that comes from wind. Um, Another 220 that comes from solar. And another 100 calories per person per day that comes from geothermal. And another 350 calories per person per day that comes from biofuel, stuff that corn basically that we grew and turned into gasoline. Okay, the rest of it, around 40,000 calories, comes from things that we pumped or mined from the ground. Okay, so we harvest roughly 15,000 calories in crops and lumber. Okay, we get around 5 or 6,000 from these sources: nuclear, hydro, wind, solar, and so on. And then we get roughly 40,000 calories from coal, oil, and gas. Okay, so um, now, of course, that's the world average. Okay, if you go to the U.S. citizens, on average, an average U.S. citizen uses 210,000 calories per person per day. That means they're effectively eating for 105 people. Okay, and there are a few small countries that use more. There are other countries that use close to the same amount, like Germany and South Korea, and then there are other countries which use much less. Okay, that's 210,000 calories plus the food, fodder, and lumber. Okay, and I'm sure that the United States share of food, fodder, and lumber is higher than the share of food, fodder, and lumber in many other countries. So now one more thing I want to add there is that, and we'll get into this later, is that the number of fuel calories that we use each each day per person has been multiplying. Okay, the world energy usage has been multiplying, and if you look at the world as a whole, okay, the world's energy usage has been doubling roughly every 22 years since around 1780. This is just the coal, oil, and gas, which still is now the majority of our energy usage. I'm leaving out the crops and the lumber, okay? But but the fact is that almost all the energy that we use for fueling our cars and our houses and factories is coal, oil, and gas. Not, and I hope you gathered from here that if 40,000 calories come from coal, oil, and gas, and still 5,000 calories come from hydro and nuclear and so on. And those numbers aren't changing that much year by year, especially since the numbers for hydro and and for solar and for wind are still down rather small numbers. So even if they're gaining by 15 or 20% per year, perhaps, then they're still not getting that big yet. Okay, and the total amount of energy use that we have, that sources that we have that are actually almost all of our energy is coming from coal, oil, and gas, no matter what you hear in the press. Okay, and so the question, and so I was trying to say, since 1775, that amount of energy from coal, oil, and gas has been multiplying every 22 years or so. It's been doubling, multiplying by 2 every 22 years or so. It's doubled many times. It's somewhere around 1,000 times more than we were using in 1775. And in the meantime, people talk about this as a population growth problem. It's not. Population might have multiplied by 8 in the meantime, not by 1,000. Okay, per person, an average person is using far more energy than we did, and we have a kind of expectation that our children will have twice as much energy as we do now. Our children will have twice as much of everything as we do now. That's the way it's been for a long time, and we think that's the way it's going to continue to go. So here are some questions that you might find intriguing, and I certainly have found intriguing, and I'm going to spend quite some time discussing them. Is, can we keep multiplying our energy use by 2? And if we can, how many more times can we multiply? Can we do it 1 more time? 2 more times? That would take us 50 more years. 3 more times? That would take us to 75 years from now. Or can we do it at all? Okay. And if we can, fine. If we can't, then what happens? Okay. Or can we even continue using 46,000 calories per person per day plus the 15,000 calories from others, from crops and lumber? If we can't, suppose we have to use a smaller amount on average, what happens then? Okay, and that's what I want to talk about. And overall, I think, things can't multiply by 2 forever, except in science fiction movies. Okay. So when is that going to stop? Or is it already stopping? Did it already stop some time ago? And how do we prepare for whatever comes next? What is that going to be like? And what are we going to need to be like to live in a flourishing way, in a way that's well adapted to the new world that we're about to enter? So what I hope that this channel and ultimately the book may do is may help you find a better way of telling the story of the human race and of the people that you grew up with and of your own family. I hope that it may help you understand how to live in a way that's satisfying and that is more likely to bring good results for you and for your friends and your family. A way that's well adapted to the future, and I hope that gives you a hope and some kind of meaning, because we're certainly in the midst of an adventure. We live in unique times. These last 250 years have been extraordinary, and the next 250 years are also going to be extraordinary, but in a different way. And what to do about that, that's all the makings of an adventure. Okay, I think that's it for this episode, and I hope to see you again. Okay.